here we are going to build a project on image stegnography. So image stegnography is a process where we inject or add a hidden data into our image. Now we have different ways of doing that, but in this video we are going to use LSB or least significant bit to inject our data. Okay, so we have a basic setup. We just have an input file and our JavaScript file. And here we have a reference to our input field, and here we have a add event listener. Whenever a file is chosen, we will just console that out. Let's see whether it works or not. So yeah, so here we have our file. One thing I want you to understand is that this thing is the reference to our image and not really the data. Browsers like Chrome or any other browser does not allow you to have the access to the client's operating system, so we cannot have access to files present in the client's PC. So one thing I want you to understand is that browsers don't allow you to access the client's file system. So this is for security reasons. That is why we can only we only have the access to their that is why this thing only gives us a reference to the image whenever we choose an image like this. So internally what happens is Chrome browser or any other browser, this will allocate the rights to access this file. So now when I did this, now I have the right to access the binary data of the file. To access the binary data, we have to create an array buffer like this. Let's just const file ref. This is a asynchronous process, so that is why we will use async here. So now we have the binary representation of our file. However, we cannot just directly console that thing out. This doesn't work like that. So we are going to convert this binary format into something more readable, like something like unint. So we have different methods where we can convert our binary data to anything like unsigned int of 16-bit, or we can even have 32 bits or 8 bits. So we are just going to allocate 1 byte for our project. It's not necessary, you can use anything you want, but for our project I am just going to stick with 1 byte of data, which is 8 bits. This is our file data. And we will pass our binary data. So this is now going to convert it to a readable format. This is 1 byte, since as we have seen this is 8 bits. 8 bits is basically 1 byte, and 8 bits is basically 1 byte. And since we are using unsigned int, it ranges from 0 to 255. So each pixel now has the value between 0 to 255. We can see that too. So let's just pick a file. Yeah, here we can see a array buffer. Sorry, I actually rendered the wrong thing. So yeah, so here we can see the image in 1 byte format. So now here we can see the image is converted into an array with each pixel having the value between 0 to 255. Now we need our message. Let us suppose const our message is this. This is some random text, and we want to hide this inside of our image. So our first step will be to convert this message to binary format. Let's just make a new function called const string to bin, string to binary. Here we will pass our message. Okay, so for let's just make let ANS will have the binary representation of our message. Let's just alliterate over each element in the string. Let I equals to 0, I should be less than message length. Okay, so now we have to convert the string to binary format. For that we will need character code. So each character has its own code. So this is a special function which will give each character its corresponding number, and in this function we have to pass the index. So this is going to give we can just console that out if we want to see this. Let's put a here. Let's just see. String to bin. Yeah, so we can see all the character codes. For example, small a has the character code of 97, and B will have 98, C will have 99, just like that. So this is all the character codes. This function returns us the character code. Now we don't want this character code though, we need the binary representation. For that we can use toString method, toString, and we will pass 2. So when we do that, this is going to convert this number into a string format, which is a binary string format. We can see that. Let's just choose a file again. Yeah, so this is all the binary number. The character codes are converted to their binary format, but they are not regular. As we can see that in some places we have 7 characters, in some places we have 8 characters. This is going to give us informalities. So to fix that we have to add padding. We will add padding at start such that each binary code is of length 8 and the empty spaces will be filled with 0. Let's see this. Okay, so I just messed up the positions. Okay. Yeah, so now you can see that each and every character code has a length of 8. Also, since we need to decode this message too, we need a special character identifier which we will use to decode our message. So this identifier will act as this identifier will tell us where is the ending of our message. So I can just add here message equal to message plus hash. So now this hash will represent the ending of the message. Binary message. Okay. Now we have binary message, we have file data. Now we just need to combine them both. So for let I should be less than. Now we will alliterate over each bit in our binary message, and we will add that to each pixel in our file data. So file data of I equals to file data of I. Now we have to we need to add the bit of this message to the least significant bit. In order to do that, to represent a binary number in JavaScript, we use 0, then B, and then our binary number 4, 5, 6, 7. So first 7 bits will be same as, okay, we will use an AND operation so that the first 7 bit of this file data is same as this file data, and the last bit is set to 0, because we are going to store our message in this last bit. We are going to OR it with our binary message, but since binary message is a string, we have to first convert it to a integer, and we don't need to worry about converting it to binary, because binary representation of 0 and 1 are same as decimal. So yeah, we can just leave it like that. For example, suppose if file data of I is like 4 bits 111. So I have used a hyphen just to make things more clear. Let us suppose this number is present in file data of I. So what is going to happen now? Let us suppose that bin of message here is 0. Okay, so let's file underscore data of I is this number, and our bin underscore message of I is 0. So what will happen now? Since it is a string, we convert it to the integer, and since the integer representation is same as the binary representation, we will leave it like that. Now when we the file data is then AND with 0b 1 2 3 4 5 6 7 and then 0. This will result into 0 1 0 1, then 1 1 1 1 1 1 0. And now since our last digit of bin message is also 0, the final result will be 0, because since this side is 0 and this side is also 0, so the last digit now stores our binary message. Okay. But this is not going to give us correct answers. If I open an image, let's If I open a image in like notepad, okay, so here we can see a header such as ampersand or this special sign and then png. So this is called image header. An image header is the thing that tells image viewer apps that what is the format of the image. So if we mess with this thing, the image viewing apps will not recognize how to decode our image. So we cannot mess with this thing. Thus, we need to add an offset. Offset can be anything. The only thing we have to keep in mind is that it does not mess with our headers. So like we can create a const offset like about 100 pixels. So we will leave the first 100 pixels, not exactly pixels, the metadata, and after that we are going to add our message. So here also this is an important step, because if we don't do this, we are going to change the headers of the file, and the final image which we get will not be able to read by the image viewing apps such as, what is this app called, pictures, yeah, photos. This photos app won't be able to open our final image. So let's see now what is our new image look like. Let's console file and let's just see the original image. Let's see both of these images. File data. So do we have a difference though? Yeah, since we are not setting the first 100 bits, so first 100 bits won't show any difference. Yeah, it's exactly the same. For just to show you that it changes, we will remove that. Yeah. Okay, so we actually made one mistake, that we didn't return our answer. Yeah, so return answer, and now let's see whether it changes or not. Why did we only get a single console? Okay, we made one other fatal mistake here of not defining our length. It's gonna lag now. Yeah, it should work now. Let's see. So yeah, we can see that our original array and our new array is slightly different. Since we are making changes only in the least significant bit, the maximum difference we can get is of 1. For example, here we have 1 difference, here also 1, here also 1, here also. Yeah, and here the v at 10 we have the same, because we can have a difference of either 0 or 1. So the pixel values are not going to differ a lot. Thus, visually you won't be able to find any difference in the image. Okay, so since we have now added our data to image, we now need to just download the image. Now we have to go to the exact reverse process. Since we first get the binary data of the image, then convert it to unsigned integer, then we did the operation. Now it's the exact opposite. We need to reconvert it to a binary representation. For that, we can use this const new binary image is we need to use blob. Now we will pass our data, file data, and file data, and we also have to mention the type. Now type we can get by file ref dot type. So now this new bin image contains the binary representation of our new file. Okay, now we can create a URL, new image reference. So URL dot create object URL of our new binary image. So this will create a reference URL. Now we can use an anchor tag to download this image. So let's create an anchor tag. We'll create an anchor tag. We will pass anchor tag dot href to be our new image reference. Now since we want it to be downloadable, we have to put download and the file name. Let's just put output. Now we have to attach this anchor tag to our body. For that we can do document dot body dot append child, our anchor tag. We will append this anchor tag to our body. So now we can just do anchor tag dot click. This will trigger the download. Now last step is to clean up, remove this extra things we added. For that we will first remove our anchor tag. So document dot remove child anchor tag. Then we will also delete this URL. For that we have URL dot revoke object URL, and we will pass our new image reference. Yeah, so then let's see. Yeah, one thing we forgot. Yeah, actually I want to show you this. If we did not add the offset here, we will mess with the header of the image. So let's just show you why it matters. It is downloaded, and yeah, we can't see this image because we are modifying the headers. We have to add this offset. It will just ignore the first 100 elements of the array, and after that we are going to add our binary message. Let's do this again. Yeah, downloaded, and yeah, we can view our image and the data is added to this image. So successfully we have added the message into our image. Now our step will be to decode this image. Let's see how are we going to do. Let's create one more element. Decode. Get element by id, access our input file, decode document So whenever a new file is added to the decode input tag, we will run our function. The same task, we will first access the file ref, which is e.get.files of 0. Now we have to access the binary data of our file. For that, file bin, which is we are going to use array buffer for that. Array buffer, and it's an asynchronous task, so we will use await, and we will convert this to an asynchronous function. Now we have to convert our binary data into something readable. We will convert it to an unsigned 8-bit integer array. Now we can start our decoding process. Let I is equals to 100. Since we have used an offset, so we have to start from that index where we have added our first bit of data. I is less than file data dot length. J equals to I, while J is less than since we only need the last bit of each number, we will do something like this. 10. Now this is a number we have to convert into binary string, and we have to add padding, and we only need the last bit. This 8 characters will combine together to form this. The loop will run for 8 times, and during this time we will add the bit to this character thing. Character is, so now character contains the binary string of the corresponding character, so we will have to convert this into character code. For that we have a method from character code. Now we have to first convert this character to number. For that we are going to use parseInt, and we will transfer the binary string, and we will mention that this is a binary string. So this function converts the binary string into number, and this function converts that number to the corresponding character. Message. So here we have added everything. Now if you guys remember that we have added a hash at the end of the encrypted message. So if this loop finds our hash, then this is going to just end the loop. And at the end of the day, so So here we got our decrypted message. This is some random text. So it works fine. So that is it for the day.